So for today's webinar, we have another consumer part that we're excited to show. So this past week, just circumstances aligned, and I happen to have a lot of surfacing questions that people were asking just with my day job here, supporting our products. And I figured I would select a really cool application part that had a lot of surfacing stuff in it, that then I could also use some of those questions that people had asked me, and use those for this RE Lab webinar. So today we're going to cover a consumer product. It is this Lacrosse head. It's just the head from the lacrosse stick. And for those of you that are unfamiliar, this is a sport, because this webinar gets seen widely around the world. So this is a sport here, primarily popular in the Northeast, right, where you have this lacrosse head here on the stick, and we reverse engineered like a legacy model here to show, and it's got a lot of surfacing stuff in it. So I definitely wanted to use this to show some of the really neat, creative modeling approaches that were taken on this, and then some of the skills that are necessary to be able to model this. So we'll go ahead and jump right in, but before I do, we'll talk about what scanner. So with this one, it was an ARM type scanner that was used to 3D scan this, and we scanned only the top of it, so a little bit is missing on the bottom, because it actually has a net on it normally, right? The model does. So the actual part does. So we used this ARM scanner to collect this information. But obviously, you could use a variety of scanners to do this one. This is one of those devices or objects, that you could use multiple devices to get really good data on. You could use, you know what I mean? It's an easier thing to scan, so many of these devices would allow you to do so as long as they fall within the accuracy range that you're trying to achieve. So with this one, again, I think it was an ARM primarily that was used to scan this thing. And let's go ahead and dive into the Design X application, because I have a lot that I want to cover today. So as usual, we always start out by just going over this slide, and I will pare it down, as a lot of people are watching my webinar on a regular basis. I know that going over this slide could take a few minutes, and it's redundant for you, but I just wanted to make sure that anybody that's watching this for the first time understands what Design X is really quick before we dive into the application. But Design X is this software right here. It's the software that we use. It is a software that can work with 3D scan data from a variety of different inputs from different devices like these over here on this side, from structured light scanners to laser to handheld laser structured light scanners, time of flight scanners, CT scanners even, all kinds of different devices. We're creating this type of data, and people were trying to load it inside of CAD, and we're struggling a lot because CAD wasn't designed for this type of information. Enter Design X. We create this software that is a parametric CAD modeling kernel with a 3D scan kernel all in one space, right? So then we take this data, do the heavy lifting, and then we extract model information and output it in different sources like you see on the right hand side, whether these are the high level outputs. CAD is the primary, but we also go straight to CNC packages or straight to additive technologies out in the market. So that's what this Design X product is all about. Grabbing that scan data, recreating or reverse engineering that object, and getting it out to whatever is going to produce that manufactured model. So with that, we'll go ahead and jump right into the Design X portion. So here is the final model of the Lacrosse stick head. And as you can see, I like to show the end result first, so you can see in all of its glory what we're going to end up with. And then we'll go ahead and jump right in. So let me go ahead and roll back somewhere around here. Turn on the mesh. There's the original scan. Like I said, we only have the top. They didn't scan the bottom, although they could have, but the neck sometimes hangs depending on the stick or style and whether it's male or female sports, because they have different regulations on the depth of the netting here or the pocket. So that was all cropped out. Shame we don't have that scan, but that's what that was there is the netting. Yeah, so that part of it is cropped out. And before I jump into the presentation portion, as usual, I'm using my trusty 3D Connection 3D mouse. And one thing that I point out every so often on here is the fact that I love my 3D Connection 3D mouse. I've probably been responsible for quite a few people buying them because I always use it and I show it and I acknowledge to people. It's nice because it makes rotating and translating the object on screen the same regardless of the software you're in. And I love that it kind of unifies the idea of rotating and translating, and I don't have to remember weird shortcuts for each different software, especially 3D people like us that are bouncing between tons of 3D softwares. That it just makes it so much nicer to be able to do that. And if you've done any design work for any amount of time, you know that with Design X, you're doing things like I'm turning on and turning off the mesh, turning on, turning off, turning on the solid. And what I have done is I've set shortcuts. Actually, let's just do this real quick. I'll just roll back down to the end. I've set shortcuts in the plugin here for the 3D connection. So I can say, okay, turn the solid on, turn the solid off, turn the solid on. It's just a click of the button. Turn on the surfaces. And whatever surfaces happen to be showing, it will show them, by the way. This is the same for the others as well. So if that surface is showing when I hide the others, you'll see boom, boom, boom. And it doesn't make that sound effect that I just made. You get the point. But it just makes it so much easier because hide, show all the time. That's just the natural process and routine that you're doing inside of Design X, which is so nice. And then you open the plugin itself, and here I will give it a second. There we go. It finally opened up. You'll see here, I'll toggle over to my Space Pilot. That is the mouse that I'm using, the 3D mouse. That's what I call it anyway. Some people call it space ball, by the way, because these people invented the space ball originally that then kind of evolved into this. And you'll see mine is discontinued. Now, that actually should be a testament to the quality of these devices because mine is a special Geomagic one that we ordered years ago when we did a deal with them. So mine has a Geomagic logo right here, the old school logo right there on the mouse. And I've had this thing for 10 plus years. It's got to be 10 plus years. Used it all the time. Love it. And a couple years ago, I believe now, We we did more work on the USB driver for 3D connection. Even in this last release, they sent us over some information to tweak and upgrade this as well. But when we did this a couple years ago, you have your advanced settings, which you can set. One thing that I always tell people, there's two types of people that use this thing. There's the people that zoom by up and down, zoom with forward and backward. If you don't like the mouse, if you don't like the 3D mouse, open it, change it from forward, backward to up, down, because I think it defaults to this one. And if you do, like, try that and you still don't like it, I'm sorry for you. I don't know what to tell you. But if usually this is what it is, there's two types of people. It's like if you're a gamer, I'm not really a gamer, but some people are like, they're all about inverted or not on the game controllers, right? Uh, it's kind of like that. There's two kinds of people, and you can switch between them, and that will either make you love it or hate it most of the time. And then the other thing is the buttons. So what I was just talking about, I can turn meshes on and off, surface bodies on and off, and if I just click on one of these, you see that we added this Geomagic Design X portion, and you can select commands or like we exposed a lot in here. So the visual properties, right? Being able to turn on all surfaces on and off, that in here. So that's what I did. You could customize this to the nth degree. I also did regions, so you can turn regions on and off as well. And then you can go crazy. The other thing is it also integrates with regular software, not 3D software like Outlook. So I even set buttons on here to delete emails, mark unread, things like that, mark as spam. So those sort of things you can do even with, and I like their interface of how they do the customization better than even like Logitech stuff. And then the other thing is, because I was such a fan of this, I have both of these, the CAD mouse. I love it. You can customize these as well. And one life hack that I do is I set these buttons here on the side to escape or enter. So that way my mouse travel, I don't have to go all the way up here to either accept a command or escape out of it. So I love doing that as well, having escape enter for that on my CAD mouse as well. So enough of my little commercial. I'm sorry if you guys are not big fans of that and you feel like I wasted your time. I apologize. This is free, so I'm sorry. Now let's go ahead and roll back like I was originally going to do before I jump forward with my rant on Space Mice. We'll go ahead and roll back here. I will say this is another hack that I've expressed before, is sometimes I'll just create a point in space, just one of these points at 0, 0, 0, and I use these points sometimes as a marker in the history tree. Right? So you see here, that's just telling me where to roll back to. Sometimes people want to mark something in the history tree to remember where that feature is that you're always editing, right? There's reasons why you might want to do that. So I point that out because it's a really neat little life hack. So we went ahead, we started off with the sweep, and we'll go ahead and turn that sweep on. This sweep is kind of interesting. If I hide the mesh, you see here we created a sweep. At first you're looking at it's no big deal. But the way they did the sweep, I like the method. Because you're trying to model something that's behind this bumper pad here, they went ahead and drew a curve along to try to find the profile of that edge. And then they drew a vertical curve down here, and they drew another vertical curve over here. So if I hit edit, there's the vertical curve there. So they did a sweep with a profile and a guide curve to model down. Just a neat method. So those of you that do a lot of modeling, you might think that's cool. I don't know. Other people might be, what's the big deal? But if you've tried to model in here and you've tried to model parts there are always really neat tips and tricks that you discover along the way that are so valuable that can save you hours, right? And that's one of those ones that like, oh, I never thought of doing that way. I got to keep that in mind for next time I'm doing a project, so that it comes in really handy. So if I go ahead and hit next, we did a lofted surface and then an extend there. Now this loft is very interesting because they did a loft. Most people, when they look at this, might say, let's do a loft this way. Draw lines down, down, down this way, and then loft between all of them. Well, they did a loft with parallel lines this direction, horizontal, I mean. And they lofted from here to here to here instead of doing this way, because I think most people intuitively would think to do it that way. So that was an interesting method of doing it that way. As you look at the part, how would you model this part? That's another one. And then here we go. They did the same thing on this side too, where they did a horizontal loft instead of vertical loft. And then they do the extends. And then we do a couple extendies. And I apologize for people. Sometimes I make up words. I'm sorry. And we're going to trim it. Now that trim actually was an interesting method. So they drew a curve on the top. They just drew a single curve all the way down following the top surface there. Then they used that single curve to trim the surface. It's close enough that they can still trim the surface with it. And they did it both ways here. So they trimmed both front and back surfaces with one curve. And then from here, there we go. Then we do some trimming, lofting. So again, this is kind of a different way to think about it. They lofted from here to here, a loft between the surfaces, and then flip the normal. And then I think they start working on the other side now. So we'll come over here, flip it over, and they did a mesh fitting to this surface here. And then roll forward. There. So now, roll forward. Now we're doing the same exact thing, actually. So we did the mesh fit, like I said. Now they drew curves. And we're going to trim those. Trim. And then, so back up here. So we trim those. Let's roll back. This is very creative the way this was done. So turn that off. We have this surface here that we fit and trimmed and created a shape. What they want to do is take this edge and extrude it and trim it with these surrounding areas, right? So instead of like doing all this work to create another plane or whatever and extrude it up or whatever, they decided to take this and thicken it. It inherently creates surfaces on the side, normal to the surface of that surface of the surface. And then delete the face, or two faces, the top and the side. So now we created this pocket to then trim with the surrounding surfaces. I thought that was a creative way of doing it. Maybe y'all thought, you thought about it yourselves already. You know how to do that. But I thought that was a neat way to go about doing it. It saved a lot of steps, right? When you're just trying to create a vertical surface edge there. This happens sometimes where you have a surface and then it needs to trim with the surrounding. So if you just did a thicken, delete the top sides and then trim it in. There you go. Problem solved. Now Jump forward. They just drew a 3D curve here from there to there and hit trim. Trim with a curve. That's the popular theme here. Trim with curves. Now we're doing these two. There we go. They drew these 3D curves on the surfaces, and what they're going to do from there is do two split faces. So split face, it's just going to say divide this into two pieces, even though there's still a surface kind of grouped together. And then from there, loft between the inner and outer like that. And it also makes it so they're the same size, and then you see what we're doing there. Trimming this all together. Now we do a sew, which essentially merges it, groups it, and makes sure that the edges are unified. So we'll go ahead and turn this off, turn that off. And then we extend. Now this was interesting because I never would have thought to extend that. You see this rollback? I never would have thought that would work. And I'm not saying that Design X is not good. I'm just saying with 3D stuff and 3D modeling, sometimes it's like, will that even work? Will that create intersecting geometry? Will it be able to solve, right? It did it. So that's pretty cool that it was able to extend that. And then from here, they take that inner and then they take the edge. We'll just open it here. So the path is this edge here and the profile is that edge there. And it's they're going to sweep it along that. And then trim, trim, trim. Well, actually, they do extends in all the directions. From there, we trim in all directions. So there we go so far. Turn the mesh on. Check our progress. Very neat. And now we're going to do some fill faces on the edges. Solid. So you see we did a fill face on both sides. Very cool, the process so far. You see why I like this? I think everybody's starting to get why I like this model. From here, beginning the next phase, we go ahead and do a 3D sketch. It looks like what we're going to do is we're prepping to trim some stuff because this is not what the final geometry is. So let's draw some 3D curves on here and create these shapes. Do split faces. And remember, just because it's a solid doesn't mean it has to stay a solid. So there, we go ahead, we take those, trim it, trim a hole that then we can do another fill face. Now you could have done it, there might have been some other ways of doing it. Instead of doing that, you might have been able to just, that worked. You might have been able to do a cut with surface too, but like that worked. That was probably the best way to do it, I think. Now we're going to apply some fillets. Let's just go ahead and fast forward. Fillet. So looks beautiful. And looks like we're going to do an offset surface. And this is an actual offset surface, not an offset 0 like we were talking about before, right? So we offset that. And then here is a really neat piece of functionality I love. So turn the mesh on. They offset that out, whatever millimeters. And this polyline, often forgotten about tool, where you can actually, right here, you can calculate a polyline, from a lot of different things. Actually, I might put a note that we need to cover more of these polyline methods. And you have these different options here for intersection. So you can intersect an object. You see here all these different objects that you can intersect to create polylines. And that's what they did here. So I'll just get out of there and just kind of collapse, do some housekeeping. Now, turn surfaces off, solids. It intersects with the mesh to create a polyline. Even hide that. There we go. Then they come in, create a 3D sketch. And we will turn that on. So we went ahead and drew that on the offset surface, by the way. So surface, we drew it on there. Then we trim it. Very cool. Then we thicken it. Into a solid. And we'll just do a little bit of housekeeping there, keep it going. Then we will do another. So this one is offsetting it back in between and cutting, because I think what they did there is they went ahead and offset and then cut the top off of that thicken. Yep. Now we come over, create a 3D sketch. Let's just hide some stuff. See, we're drawing some 3D sketches, lofting. All right, so what's going on here is the way the actual thing goes, it comes down and merges in. So we offset it and it's a constant thickness. So they are drawing from here down a swoopy shape, and we are fitting a surface to it. And let's just do, again, a little bit of house cleaning there and creating that. So that way we're going to, you see where we're going with this. We're going to extend that in some different directions. Then, because of where I jumped forward, after we extended it, we trimmed these back. We loft between the surface that was there before. You know, we sew it back together. We then trim that, thicken it. So instead of doing this with surfaces, we're going to do it with solids. We trim that, and then we're going to Boolean this from that. So now we got what we wanted, right? We got it to like come down and intersect with the mesh, or intersect with the, but look at what we did. Because of the way the surface is a little bit ripply, check this out though. All is not lost. We can draw a couple curves on each side, blend those by doing a loft. Oh, actually, we did not. This time, instead of doing a loft, you could do it that way as well. We did a delete and replace and repair face. So that saves some steps. And then we We filleted the end to make it dive down. And there we go. So let's forge ahead. Okay, so now we did another offset surface to the inside, I believe. We did another polyline, and that one is really to then make sure that we gather all of that information there. So you see that now we have all of that to go off of. And you see what we're going to do is we're going to then trim the surface with these 3D sketches. So come up here, turn on our surfaces, trim that surface with our 3D sketch that we drew from these reference polylines. So like you can use that to draw, and then go crazy thickening, and then Boolean from the shape. I'm liking it. So now you can see here modeling this guy, turning this on just so we can see the reference, because this it's not over. The show is not over. This is an interesting piece of geometry down here too. So we go in. They're going to draft that, Boolean it together, make it one piece. Roll forward here. Okay, so they cut away because there's a pocket that they cut out there. And let's just turn this off so we can see. And we'll hide those reference polylines. We don't need them anymore. So you see there, they extrude, just do a regular solid extrude from that direction, then loft from the end of that to the end of that. And since they're both four-sided with different proportions, you're able to whoosh, all the way over and up. Now, jump forward. All right, so we're actually, let's roll to this. We went ahead and lofted to create that shape. A move face to make it completely intersect, or almost completely. You'll see that I think some of that gets cut away. Boolean merge these objects together. We did, here's our surface 0, I believe. Surface 0. Extends and then cut. And there you go. Now do another surface offset. This is another one of the surface offset zeros, right? We're basically just duplicating that face in order to cut the interior piece and Boolean it in. And then, of course, we can hide that. So very interesting there. And then from here we have Fillet City. Fillet it up. Fill it out. Okay, and then we're on the home stretch here. Oh, cutaways now. So cut the holes, normal to, just fittings, planes, and finding the directions there. So let's just jump forward all of those holes and slots, and great. And then mirror it across, and we are home free. And then they applied some other fillets too to blend everything there. So neat little model.